Let's begin our discussion on coordinate geometry. Now, we have to discuss all these points in coordinate geometry, and I have written them so that I don't miss any of them. The first point that we have to discuss is what is Cartesian system? What is the Cartesian system? Well, Cartesian system is named after a popular mathematician René Descartes. René Descartes gave us the method to tell the position of a point in a plane. Okay, so let's quickly discuss about plane. What do we mean by plane? Imagine that you are holding a sheet of paper and that sheet of paper has no thickness whatsoever. Okay, and you cannot see its edges. That's what I have represented it using dotted lines. These dotted lines tell you that this part extends to infinity, this part extends to infinity, this part extends to infinity, and same with this side and this side. You cannot find its edges. So imagine that you are looking something in the air, and you are imagining a sheet of paper that extends to infinity, and it is two-dimensional. Since it has no thickness, it has only length and it has breadth. It has length and it has breadth. It has no thickness, that's why it's a two-dimensional figure. Plane is a two-dimensional figure. Okay. Now, so we have discussed plane, Cartesian coordinates. Okay. So what René Descartes told us that you can tell the position of a point in a plane. Imagine that this is your point and you can tell its position, and we call it Cartesian coordinates. Cartesian coordinates. We tell the position of a point by Cartesian coordinates, or simply coordinates. We'll discuss more on it in detail, or simply coordinates. Okay, so we are done with Cartesian system, we are done with plane, we are done with Cartesian coordinates, number lines. So imagine that we know that we have studied earlier about number lines. This is a number line and we have represented it by x, o, x dash. These are the points. This is 0, that is the origin. This is 1, this is 2, this is 3, this is 4, this is 5, and so on. This is -1, this is -2, this is -3, this is -4, this is -5, and so on, right? This number line we have studied in our grade 6, grade 7, and grade 8 mathematics and all. Okay, now same thing is this vertical number line. This is horizontal, this is vertical. So this is origin, that is 0 point. This is -1, this is -2, this is -3, -4, -5, -6. This is 1, 2, 3, 4, 5, and 6, and so on. Okay, now this vertical number line and this horizontal number line, let's take this vertical number line and imagine that, okay, it needs some space here. Let's keep it here. I need to move it. Control X and V. So it's here. X and V. Okay. So we take our vertical number line and the horizontal number line, and they intersect at the point which is called the origin. And what's origin? By origin we mean that this point where it is denoted by either O or 0, right? And this is the origin. Intersection point is the origin of this horizontal XO X dash and this vertical number line, that is YO Y dash. This intersects here. So this is about number lines that we know. Okay. So number lines xox dash axis and yoy dash axis. So this is one axis, we call it yoy dash axis, and xox dash axis, xox dash axis, and in short we say that x and y axes. This is plural of axis, plural of axis. Okay, so xox dash axis, yoy dash axis, and coordinate axis. Okay, now this was our number line, and this was our number line, and this was our plane, right? This was our plane. So what we have actually done here is we have divided this plane into four regions, The four regions are called quadrants, Okay, what are quadrants? This region is quadrant 1, this region is quadrant 2, this region is quadrant 3, and this region is quadrant 4. What do we mean by quadrants? That is, a region is divided into four parts. So this plane has been divided into four regions, and the regions are called quadrants. First quadrant, second quadrant, third quadrant, fourth quadrant. That is, we are actually moving in anti-clockwise direction, anti-clockwise rotation. 1, 2, 3, 4. Not 1, 2, 3, 4, but 1, 2, 3, and 4. Anti-clockwise. Okay. And we have these four regions due to these two axes, that is xox dash and yoy dash. These two axes are called coordinate axes. Coordinate axes. X-axis and y-axis. So coordinate axis. So we have four regions due to these two coordinate axes. Okay. Okay. So now, if you look at this region, that is region 1, in this region 1, all the numbers on OX are positive, all the numbers on OY are positive. So this OX is positive, this OY is positive direction. On the other hand, if you look at OX dash is negative and OY dash is negative. So we have two positive directions, OX and OY, and we have two negative directions, OX dash and OY dash, right? So this plane has been divided into four regions called quadrants, and we have four quadrants due to these two coordinate axes, and this is quadrant 1, quadrant 2, quadrant 3, and quadrant 4. Then we have origin, we have discussed, positive and negative reactions we have discussed, and we have quadrants we have discussed, Cartesian plane, coordinate plane, or XY plane. Okay, so whatever we are looking at here, that is, since this plane has been divided into four regions due to these two coordinate axes, therefore we call it a Cartesian plane. We call it the Cartesian plane, or we call it coordinate plane, or we call it the XY plane. We call it the XY plane, where this is the origin. Okay, this is the origin of this plane. Of this axis, and we have four quadrants, and this plane has been divided into four regions called quadrants due to these coordinate axes. Okay, then we have abscissa and ordinate. Okay, so now you have understood this one. let's take this point here on the graph paper. This point, this discussion on the graph paper. Now you know that each unit here is actually equal. This is 1 unit, this is another 1 unit. The same thing is here, that is the space between each number is actually equal. So the space between two numbers is called 1 unit, and all the spaces are actually equal. So that is important. Now when we take our discussion on this on a graph paper, now again we have y-axis, and we have x-axis. Now this is the origin, Now you can see here 1 unit is actually equal to 2 blocks. 1 block and 2 block will represent 1 unit. Again 1 block, 2 block, another 1 unit. 1 block, 2 block, another 1 unit. So here 1 unit in our discussion in this graph, our 1 unit is actually equal to 2 blocks on this graph paper. That is really very important. Okay. Now this is quadrant 1. This is quadrant 2. This is quadrant 3. And this is quadrant 4. Imagine that if I ask you, can you tell me the location of this point? Right? Can you tell me the location of this point? Let's say that this is point P. So you will say that, hey, that's very simple. I'll tell you how. First, say that you have to tell the coordinates of this point. Position of this point P means you have to tell the coordinates of this point P. What you have to tell? You have to tell coordinates of this point P. Coordinates. And the coordinates, each coordinate has 2 parts. One will be abscissa and one will be ordinate. Abscissa and ordinate. Each coordinate has 2 parts, abscissa and ordinate. Abscissa tells us the x coordinate. Don't worry, I'll explain you in a very simple way. This tells you about the x coordinate and this tells you about the y coordinate. Each coordinate, you have to tell the position of this point P. It means that you have to tell the coordinates of this point P. The coordinates has 2 parts, abscissa and ordinate. Abscissa tells you the x coordinate and ordinate tells you the y coordinate. Like here, this point, can you tell me how far this point is from the x-axis? Now clearly you will measure 1 unit, 0 to 1, 1, 1 to 2, 2 unit, and 2 to 3, 3 unit. Okay, so from 0 to 3, write this abscissa here. That is, it will tell you the distance from this y-axis. You have to count the number of units on the x-axis. The number of units that you count on the x-axis is actually the distance from the y-axis, right? So it's actually the distance from the y-axis. So the distance from the y-axis means that just you have to count the number of units on the x-axis. That will tell you the abscissa or the x-coordinate. Okay, then you put comma here. Now you have to write the ordinate. Ordinate means the y-coordinate, and that means the vertical distance of that point from the x-axis. And for that, what you have to do is just count the number of units on the y-axis. Like here, when we wrote here 3, it means that 1 unit, 2 unit, and 3 units on x-axis. So on the same way, when you have to write the y-coordinate, it means that you have to count the number of units on the y-axis. So 1 unit and 2 units. That's basically the distance from the x-axis. So write 3, 2. Is it clear? Okay, let's take one more example. So this is point P. You will say that coordinates of this point P is 3 abscissa or x coordinate, comma to ordinate or the y coordinate. Okay, let's say that you have to tell the position of this point. Let's say that this point is Q. Okay, so you will say that, hey, that's very simple. I have to tell the coordinates of this point Q. Now the coordinates of this point Q has two parts. First part is abscissa. Let's count the number of units on this x-axis, and that will tell us the abscissa. So when you count this is actually 6, right? So when you find the distance from the y-axis of this point, it means that you have to count the number of units on the x-axis. So 0 to 1, 1 to 2, 2 to 3, 3 to 4, 4 to 5, and 5 to 6. This is the distance from the y-axis of that point. So you write it here, 6. Okay, comma. Then you have to tell the ordinate or the y coordinate. For that, you have to measure the distance of this point from the x-axis, this one. And for that, you have to count the number of units on this y-axis. 0 to 1 is 1, 1 to 2 is 2, 2 to 3 is 3, 3 to 4, 4, 4 to 5, 5, 5 to 6, and 6. So this point is actually 6, that is x coordinate, comma 6, that is y coordinate. So this is 6, comma 6. So the coordinates of this point Q is 6, comma 6, right? Okay. Now you must have noticed one thing here, that since this is positive direction and this is also positive direction, because we have positive numbers on this part of the x-axis and we have positive numbers on this part of the y-axis, therefore each number will be of the form positive, comma positive in this first quadrant. Now let's move to the second quadrant. Okay, if someone asks you that, can you tell the position of this point? This is -5, right? So someone asks you, can you tell the position of this point? Let's say that I'm removing this. So that person asks you that this is point P. Now tell its coordinates. You will say that's simple. First, let me measure the number of units on the x-axis. That will tell us the abscissa. So abscissa is the number of units on the x-axis or the distance from the y-axis. So the distance from the y-axis is actually 0 to 1, 1. Now don't get confused by this negative sign. The space is 1 unit only. So you'll have to count the number of units. So 1 unit, 2 unit, 3 unit. And so here it should be -4. I'm sorry, it is not -5, it is -4. Okay, that's a mistake. This is -4. Sorry, -3. This is -4. So we have 4 units here. So you'll write 4, comma. Now this point P has abscissa of 4, that is x coordinate is 4, and then you will measure the distance of this point from the x-axis. That will tell you the ordinate or the y coordinate, and for that you have to measure the number of units on this y-axis. So 0 to 1, 1, 1 to 2, 2, and 2 to 3, 3 units. So 4, comma 3 is a coordinate of this point P. That's the position of this point P in this coordinate plane is 4, comma 3. That is abscissa and the ordinate, right? Okay. Sorry, this is -4, comma 3. You have to put this minus sign here. When you will count, the units will be in the terms of positive numbers, but you will have to tell at what exact position. I'm sorry, this is -4, comma 3. This is -4, comma 3. You'll have to write that exact number, -4, comma 3. So let's take one more number. Let's say that, so if this is a mistake, it should be -5 and this is -6. Okay, now if you have to tell this number, let's say this number. So this number, let's say, is this point, not number, this is Q point. Now you have to tell the x coordinate or the abscissa. So for that, you have to tell the distance of this point from the y-axis. And for that, you have to count the number of units. So 0 to 1, 1 to 2, and 2 to 3. That is 3 units. But the exact number is what? Minus 3. Minus 3, comma. Then on this particular axis, that is, now you have to tell the distance of this point from the x-axis. That will tell you the ordinate. So you have to count the number of units on this y-axis. 0 to 1 is 1, 1 to 2 is 2, then up to 7. So you have total 7 units and it is at the point 7. So write this point 7 here. Therefore, the coordinates of this point Q is minus 3, 7. Minus 3 tells you that it is in the negative direction and it is at a distance of 3 units from this y-axis. And this 7 tells you that it is in the positive direction, but it is at the distance of 7 units from the x-axis. Minus 3, 7. So like here we saw it's positive, positive. You can see here it is actually negative, positive form. That is, your abscissa will be negative and your ordinate will be positive. Negative, positive, negative, positive. Right? Okay. Now let's move to this third quadrant. In this third quadrant, if we take this point, let's take this point. Let's say that this is point P. So you have to tell the coordinates of this point P. Okay. So you have to tell this coordinates of point P. First you will write the abscissa. The abscissa is actually the distance of that point from the y-axis. And for that, you have to count the number of units that point is away from that x-axis, right? Sorry, you have to count the number of units on the x-axis. So 0 to minus 1 is 1 unit, 1 to minus 2 is 2 units. So it is actually at the point of minus 2. So write it as minus 2, comma. Now you have to tell now the ordinate. It means that you have to tell the distance of that point, the perpendicular distance of that point from the x-axis, and for that you will count the number of units on the y-axis. 0 to minus 1 is 1 unit, 1 to minus 2 is 2 unit, and 2 to minus 3 is 3 units, but it's actually exactly at the point minus 3. So you will write minus 3. Let's take one more point. Let's say that you have to tell this point Q. So this point Q, what's the distance of this point? First you have to tell the abscissa. So you have to tell this distance. You have to tell this distance from the y-axis. That is, you have to count the number of units on the x-axis. Distance from the y-axis means count the number of units on the x-axis. So how many units do we have? We have 4 units, but it is at the number minus 4. So write it as minus 4, comma. Then you have to tell this distance from the x-axis. For that, you'll have to count the number of units on this y-axis. So if you count the number of units on this y-axis, that is actually equal to 6 units, but it's at exactly at the point minus 6. So this is minus 4, comma, minus 6. So if it was positive, positive, it was negative, positive, this third quadrant is actually of the form negative, negative, because OX dash is negative and OY dash is negative, right? So can you tell what, like in this case I'm going to take just one example. So let's say that you have to tell about this point. So let's say that this is the point P. This is the point P, and you have to tell the coordinates of this point P. So first tell the x coordinate or the abscissa. So the x coordinate or the abscissa in this case is actually the distance of this point from the y-axis. And for that, you have to count the number of units on this x-axis, and that is actually equal to 4. So write 4 here, comma. Now, the distance of this point from this x-axis, and for that you have to count the number of units on this y-axis. So from 0 to 5, but it is exactly at the number -5. So right here -5, right? So it is of the form positive positive, negative positive, negative negative. This point P, you can see here, is actually of the form positive negative. That is, all the points that lie in the fourth quadrant will be of the form positive negative. That is, their abscissa will be positive, but their ordinate will be negative. Just count the number of units, but don't forget the sign, negative sign and the positive sign. OX is always positive, OY is always positive, but OX dash, this is your OX dash, this is negative, and this OY dash, this is also negative, right? So in the first quadrant, the position of a point is by plus number. In the second quadrant, it's negative plus number. In the third quadrant, if you have to tell the position or the coordinates of a point, that is given by negative number. And in the fourth quadrant, it's actually positive negative number. The position of that point P or Q, whatever that point is, the coordinates are positive negative. This is actually the Cartesian system. You can tell the position of a point in a plane. That's why we call it Cartesian coordinates. As we discussed earlier, these coordinates, that is the position of a point P in a plane, is given by Cartesian coordinates, and that is dependent upon which quadrant that point lies in, whether that point lies in first quadrant or second quadrant or third quadrant or the fourth quadrant. On the basis of that, you can decide the negative sign and the positive sign. Okay. Now, can you tell me what will be the coordinate of this point O? That is the origin, and you will say that the coordinate of this point O will be 0, 0, because this is the origin, this is the distance, this is the starting point of the x-axis and the y-axis. Therefore, it has no distance whatsoever from the x-axis. You cannot count its distance from the x-axis, and in the same way you cannot count its distance from the y-axis. This is the origin, therefore its abscissa is 0, its ordinate is 0. This is the coordinate of this origin O. Now, what else? So coordinates, abscissa, ordinate, coordinates of the origin. Okay, this point, coordinates describe a point uniquely. That's very important point. So here we were. I'm removing all these things. So the last point is actually, always remember that whenever you, if you write a point P as 4, 3, it means that its x coordinate is 4, its y coordinate is 3, that is abscissa is 4, ordinate is 3, but you cannot write this as P 3, 4, right? You cannot write it like this. This has to be the x coordinate and this has to be the y coordinate. You cannot write like 3, 4. It will mean that in this case the x coordinate is 3 and this y coordinate is 4. If you want to represent this 4, 3, that will come here. This is 4. So this is 4, 3. But when you represent this 3, 4, that's actually here. This is 3, this is 4. So this is 3, 4, and this is 4, 3. That is the distance of 4 units from the y-axis, and this 3 tells you the distance of 3 units from the x-axis. But in this case, this 3 tells you the distance of 3 units from the y-axis, but this 4 tells you the distance of 4 units from the x-axis. Both are 2 different points. You have to remember, that's why it said that it's unique representation. Okay, so this was all about, Cartesian system, plane, Cartesian coordinates, number lines, axis, coordinate axis, origin, positive, negative directions, quadrants, Cartesian plane, coordinate plane, xy plane, coordinates, abscissa, ordinate. Coordinates describe a point uniquely, and coordinates of the origin. Okay, thanks for watching.